So let's actually look at some great applications for these so you're not like, why the heck am I learning this? Because it actually is really used. So given the magnitude of a non-zero vector v and the direction angle alpha between the vector and the horizontal axes, we can write these vectors as the magnitude or the speed. This is going to be cosine of alpha I plus cosine of alpha j, just like we showed on the last slide. So in addition, if a vector represents the speed and direction of an object, it's called a velocity vector. So let's look at this example. An aircraft maintains a constant speed of 600 miles per hour headed due south. Okay, so here's our magnitude. The jet stream is 60 miles per hour in the northeasterly direction. Express the velocity of the 737 relative in the air relative to the velocity of the jet stream in terms of I and j. Okay, so we know that the velocity vector for the 737 is going to be, so it's heading south, so that vector is going to be a negative 600j. Going south, remember j is this unit vector going up 1 unit, so we're going south, so that's going to be going down, so that's why it's a negative 600j. And then the jet stream so that can be determined. Again, we've got our 600, or sorry, this is going 60 miles per hour, so our velocity is 60 miles per hour. Whenever they talk about a northeasterly direction, so northeast, so here's north, here's east, so we're going to be talking about going in this direction. So we're going to call that 45 degrees, okay? So that's going to be the same thing as, if I follow this out, the cosine of 45 degrees I plus the sine of 45 degrees j, which ends up giving me 60 times, the cosine of 45 is root 2 over 2i plus 60 times the sine of 45, which again is root 2 over 2j. So that gives me 30 root 2i plus 30 root 2j. If we were approximating that, that would be about 42.4i plus 42.4j. All right, so let's continue this. So we just got those as our answers. Find the velocity of the 737 relative to the ground, where the following is true. So the way that airlines, I don't know if you've ever flown recently, but you can kind of track your flight and it'll tell you what the airspeed is, the wind speed, and it also shows the ground speed. I don't know if you've ever wondered where does that come from, but this is where it comes from. It comes from adding that airspeed to that wind speed vector. So if we were trying to figure out what that vector would be, and then we'll go through to find that velocity. So if I were to add those two together, so we'll call it the vector for the ground speed. So that's going to be adding that airspeed vector, which we found was this, plus the wind speed vector, which we found was this. So that's going to be taking negative 600j plus 30 root 2i plus 30 root 2j. So that's going to end up giving us, if I add these together, I'm going to write the I component first, so 30 root 2i. And then for the j's, we've got negative 600 plus 30 root 2j. And we usually like to keep this not in decimal format until the very end, but if you did, or if you were asked to put it in decimal format, it's going to be about 42.4i minus 557.6j. So now we've got A, we've got B. So we have the velocity for the airspeed, the velocity for the wind. Now we have the velocity for the ground. And now if we wanted to find the actual speed and direction of the 737 relative to the ground, where the following is true. The actual speed is equal to the magnitude of the ground speed. Okay, so if I needed to find the magnitude of the ground speed. So we figured out what the ground speed is in terms of its I and j components. So that velocity is going to be the square root of the horizontal component squared plus the vertical distance squared, which ends up giving us about 559.19 miles per hour. Make sure you're using your units. Now, if we had to figure out the angle that this was going in, so the first thing I'm going to do is I want to see kind of what this vector is. So remember we said this is about 42.4 I minus 557.6j. So if I were to figure out what direction this is going in, so this is the horizontal component, so your x values are going positive, your y values are negative, so that's going to put us right here, somewhere in that quadrant, that fourth quadrant. So again, we've learned to figure out what these angles are. So you're going to take, we can figure out this angle by doing the tan inverse, so we know the tangent of theta equals the y value divided by the x value. So when I do the tan inverse of both sides, I end up getting negative 80.65 degrees. So this angle here is negative 80.65 degrees. Now remember when we're talking about bearings, we talk about from the pole. So we need that angle. So if we're talking about a bearing for the direction, we would say this is going in the southeast direction. So south, something east. So this something is whatever that angle is that's there. So we know this entire thing is 90 degrees. Oh, sorry, this is 85. So we know this entire thing from here to here is 90 degrees. I already have 85.65 taken. So what's left to make up for that part? 90 minus 85.65 leaves us with 4.35. So the direction is south 4.35 degrees east. Okay, let's look at another one of these. An airplane has an airspeed of 600 kilometers per hour bearing south 30 degrees east. The wind velocity is 40 kilometers per hour in the direction south 45 degrees east. Find the resultant vector representing the path of the plane relative to the ground. What is the ground speed of the plane and what is its direction? Okay, so we learned before taking the vector of the airspeed plus the vector of the wind speed equals the vector of the ground speed. All right, so we need to first figure out what the ground speed vector is. So we know the vector of the airspeed is going to be taking that 600 miles per hour. So there's your magnitude. All right, now I need to figure out where exactly that is on the unit circle, because this is going to be cosine of some angle I plus sine of some angle j. I need to figure out what the heck that angle is. So southeast means that you're heading south and you're 30 degrees in the eastern direction from the South Pole. So if I were looking at this angle on a unit circle, this would be 300 degrees, would be that direction. So we could rewrite this as 600 times the cosine of 300 degrees I plus the sine of 300 degrees j. Okay, so that ends up giving us 600 times, so the cosine of 300 degrees is 1/2. The sine of that is root 3/2. So then when I multiply these out together, I get 300I plus 300 root 3j. Okay, so there's the aircraft vector. Now, if I wanted to find the wind, okay, so the magnitude was 40. Now I got to figure out this angle. Okay, so the angle was southeastern 45 degrees. So south going in the east direction, 45 degrees. So if I were to write that as a full angle, this would be 315 degrees. Okay, so that's going to give us 40 times the cosine, times root 2 over 2i plus the sine of 315 is negative root 2 over 2j, which gives us 20 root 2i minus 20 root 2j. Okay, so I've got my airspeed, my wind speed. So now to figure out my ground speed, I'm going to add those two together. Oops, A plus V of W. All right, so that's going to give us, when I add these two, you're going to get 300 plus 20 root 2i. And then for the j component, it's 300 root 3 minus 20 root 2 j. So if you were to actually estimate that, that's going to give us 328.31 or 0.3 I minus 547.9 j. So we can see no matter what, we've got a positive x and a negative y. So even with this going in this direction and having a wind speed pushing that another 45 degrees, my plane is still, the ground speed is still going to end up being in that fourth quadrant. Okay, so to figure out the ground speed, so the ground speed is going to be the magnitude of the velocity of the ground. So that's going to equal the square root of the horizontal component squared plus the vertical component squared, which ends up giving me about 638.7 kilometers per hour. And then if I had to find the actual direction of it, so that's going to be finding that angle. So first let's figure out what this angle is right here. So that's going to be doing the tan inverse. So setting that up, we've got the vertical component on the top, so that y divided by x. When you do the tan inverse, you end up getting that your angle is about 59.07 degrees. Okay, so this angle here is 59.07. I'm going to draw this here again. So we've got, here's the ground vector, we've got this is 59.07. But when we're talking about direction of airplanes, we need to talk about it in terms of bearing. So this is south, east, so it's going to be south something east. To figure out what that something is, we know this whole thing is 90 degrees. I've already taken up 59.07. So 90 minus 59.07 degrees leaves us with 30.9 degrees. So it's going to be south 30.9 degrees east.